So we're starting to talk about volcanoes, and who would ever expect that volcanoes would come back to Bowen's reaction series? Well, remember that volcanoes are made from magma and lava and pyroclastics, and all rocks that come from volcanoes are igneous rocks. So when we talk about igneous rocks, of course, we need to talk about our brother-sister rocks, which you can see on the right side of this particular diagram. And those brother-sister rocks vary from ultramafic to mafic to intermediate to felsic. And Bowen's reaction series shows you the minerals that you find in each of the brother-sister pairs. So these arrows point to the particular minerals. The biggest thing about volcanoes that you need to know that on this left side here, ultramafics are the rocks that you get at a really, really high temperature, and felsic are the rocks that you get at a really, really low temperature. The only thing that's missing from this diagram is there should be an arrow coming down like this that also says that as you get towards the bottom here, you get high silica, and up here towards the top, you get low silica. And that is really, really, really important. So when I think of volcanoes, I think of one word, I think of silica. And silica makes me think of viscosity, which is how thick a molten is. So if you have high silica, then the molten will be really thick, meaning that it got a high viscosity. Things that are really thick, they don't like to flow. So they build up down inside the ground, and they get thicker and thicker and thicker with more and more pressure until eventually it explodes. And that is when typically you get a pyroclastic event. That would equal volcanoes like composite volcanoes or ash and cinder volcanoes. The opposite would be if you have low silica, you would typically have a runny molten. So molten that's really runny, meaning that it got a really low viscosity. And as a result, it's easy to flow. So it flows right out of the volcano and flows over the ground with no issue. Very quiet, very gentle. And in that particular case, we would get a volcano type typically called a shield volcano. The other option would be a lava plateau, which you're going to learn eventually. So what I just basically did was I related silica to felsic versus mafic, ultramafic. And now you know that if the molten has a felsic composition, then the volcano is going to be explosive. So you can expect a composite or a shield. If it's ultramafic or mafic, you know that the molten is going to be very gentle, very runny, very liquidy, so it's going to flow. So you can pretty much expect a shield volcano or a lava plateau. So there I am linking Bowen's reaction series and the brother-sister rocks to the gentleness or the explosiveness of a volcano, the type of volcano that you will get, and what actually will come out of it. One more thing that I kind of wanted to do was I wanted to insert a slide, and just by getting a white screen here, and I just wanted to remind you of the mineral group that we did called the silicates. We've done 7 mineral groups. This was the most important one. And at the time, I told you there were 2 different classes of silicates. One was called sialic, and one was called cemantic. Just to keep this simple, I'm just trying to make a relationship with you here. Sialic were the silicate minerals that were light in color. So they were light. And just to let you know, every single mineral that's in that Bowen's reaction series is a silicate mineral. So the ones that are light, like quartz and potassium feldspar, that is felsic. Sorry for the interruption. And the minerals that are cemantic, they are dark. And that would equate to mafic. So here we are. Now, we're taking the silicate mineral group that we learned in Unit 3, realizing that there's 2 subgroups, and we're connecting minerals like quartz and potassium feldspar and muscovite mica to being light in color, being felsic. So everything on this side would be the explosiveness of volcanoes. So your composite and your ash and cinder, and everything on this side would be your more quiet, gentle volcanoes like your shield volcanoes or your lava plateaus, which would be on the mafic side. So there's a connection between mineral groups and the minerals that are actually in Bowen's reaction series. We just connected it to silica because felsic is high silica and mafic is low silica, and making a connection to the volcanoes that you will actually get.